Hello everyone. In this video, we'll be solving problem number 20, valid parentheses. The problem statement is given a string S containing just these characters, which are open and close parentheses. Determine if the input string is valid. There are three conditions for a string to be valid. Open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding opening bracket of the same type. Let's look at example number 1. We have a curved parenthesis opening and close in the right sequence, hence the output is true. Similarly, in example number 2, we have three different type of parentheses, but they are all opening and closing in sequence, hence the output is true. But in example number 3, we have a curved opening parenthesis, but a square closing one, which is not the same, so the output is going to be false. I hope you were able to understand the problem statement. Now let's switch to whiteboarding and understand how it can be solved. So there are two approaches to solving the problem. Let's start with the most naive one. In the naive approach, we'll iterate through the input multiple times at any given point of time. If we encounter any pair of parentheses opening and closing next to each other, we will remove it. And we'll continue to do that until the length of string is equal to 0. Let's run a couple of iterations. In the first iteration, there is only this one instance where the opening and the closing parentheses are next to each other. After replacing this or removing it, then I'll run the iteration again. I have this valid parentheses pair. I will remove it. The next I'm left with the squared parentheses. Again, I'll run the iteration and then remove this as it is a valid pair. So at the end, I'm left with nothing. And because it's empty, we can say that it is a valid parenthesis and then return true. If our input was invalid, let's try that example as well. So in this case, when we run the first iteration, we will not find any valid pair, so nothing will be replaced. So, and if nothing is replaced, we'll check its corresponding length to the original length. If the lengths are same, it means we could not find any pairs to replace, so we will break out of the iteration and then return false. Our time complexity is O of n factorial, where n is the number of characters in the string, and the space complexity will be O of 1. The reason time complexity is O of n factorial is because we are running through the iterations multiple times and replacing the valid parentheses every time. So this solution solves the problem, but it's not an efficient one. So now let's talk about how it can be solved in a more efficient way. Another option of solving this is using stack. We'll use stack to only store opening parentheses, and at any given point of time, if we encounter a closing parenthesis, we will check if it is valid for the latest entry in the stack. Let me show you a couple of examples to show how this will work. So with I is equal to 0, the character at S of I, an opening parenthesis, yes. So we will add it to the stack. Increment our I. I is 1. I'm pointing at the next character, which is again an opening parenthesis. I will push it to the stack. Increment my pointer. Same as before, it's an open parenthesis, so I will add it to my stack and increment the pointer. So now we are pointing at 3, which is a closing parenthesis. So now that we have stumbled upon a closing parenthesis, so we will do a peek on the stack and check if the latest entry to the stack is a valid pair with the closing parenthesis that we stumble upon. Doing the peek, I will get a curved opening parenthesis. If it is a valid pair, so we can remove the last entry from the stack and continue the iteration and increment the pointer. Same thing would happen. We will peek at the latest entry in the stack, which is a curly opening parenthesis. It is a valid parenthesis paired with the one that our pointer is pointing at. So we will pop the entry from the stack. We'll continue to do that until the end. If the string is a valid parenthesis, after the iteration is complete, the stack will be empty. Now let's use one more example to show what if the string is invalid. So with I is equal to 0, it's an opening parenthesis, so I will add it to the stack and increment my pointer. Now it's 1. Again, I have a curly opening parenthesis, adding to the stack and increment my pointer. The next is a closing parenthesis, so I will do a peek, which will give me a curly opening parenthesis. Is this a valid pair with the curved one? No. We will return false. We don't need to continue the iteration. So with this approach, our time complexity is O of n, where n is the number of characters on the input string, and our space complexity is also O of n, as we are maintaining this stack. I hope you were able to understand this. Let me show you how we can implement this using C#. Here is my solution. I start by initializing a dictionary and add all the corresponding parentheses pair in it. I'm initializing a new stack. I then call this helper method, passing the index, the input string, and the stack. This helper method checks if the string length is greater than I, or the pointer. This is just to protect ourselves from getting out of bound errors. If my stack.count is 0, which means either we are starting the iteration or we have already found all of the valid pairs, or the latest item in the stack and its corresponding opener parenthesis, it is not equal to the character pointed by the pointer. If either of the conditions are met, we then check if it is an opening parenthesis or not. If it is, then we push it to the stack and call the helper method again. If the character does not exist as a key in this dictionary, which means it is one of the closing parentheses, we simply return false. If we confirm that the character which is pointed by the pointer is actually the closing parenthesis, it will go inside this else condition where we pop the last item from the stack and then call the helper method again. After the iterations are complete, we are checking if the response is true and the stack.count is equal to 0, and accordingly return true or false. I hope you were able to understand this solution. If you have any questions, feel free to reach out to me. The link to this source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.